Hello, Jim Morgan with the Electrical Circuits class. Hey, we're going to talk a little bit about motors tonight. First of all, I want to touch on capacitors. Last week I had a question that was, how is a capacitor measured? I said, is it microfarads, true or false? The answer is true. And some of you put false. It was measured in farads, which is also true. If it was just an oversight on my end, if there's a capacitor bank or something really large that's feeding the power plant or something like that, a large capacitor will be measured in farads. But for motors or something like that, we're looking for microfarads. I actually had my furnace quit working this week. I go down, the induction motor that brings in the fresh air was not working, and I took and I spun the flywheel, and it started turning, which let me know that the start capacitor was probably not working. So I took it out to check it, and this is what it looks like. As you can see, it's a 3 microfarad 250 volt capacitor. And so I brought my little meter home and put it on farads, microfarads. I'm going to hook these little test leads up to it. And we should have, if it's a good capacitor, 3 microfarads. And you can see we do not. It's 2.22, which leads me to believe that this capacitor is bad. So I go to the supply house and bought one for $1.49 and put it in, and my furnace is working great. And my wife's happy because we have heat. Getting to the motors, I have here an induction 3-phase 9-lead motor. And of course it's a 9-lead motor because there's 9 leads coming out of it. And all these leads are tied to the stator winding. They do not go to the rotor winding at all. The rotor is free floating. There's an air gap between the rotor and the stator, and none of the wires connected at all. It's all the magnetic field around in the stator field. And this motor is particularly, it was wired for 480, but you can wire it for 240, 3-phase, or 480, and we're going to talk about that for just a second. If we want to hook it up to low voltage, 240 volts, there is a diagram right here. See the numbers on the terminals, 1 through 9, and how you tie them together. So what you do is you take 1 and 7, and you're going to tie them to L1 coming in, your 3-phase coming in. And then you're going to take 2 and 8, and tie those together along with L2, and 3 and 9. You're going to take those 2 wires and tie them to L3, and then you're going to have 3 wires left over, 4, 5, and 6, and we are going to tie those together, and that will be wired up for 240. Now to wire up that for 480, it's a little bit different. We're going to take 4 and 7 and tie them together. We're going to take 5 and 8 and tie those together, and 6 and 9 and tie those together. Now, I'm not going to be able to try this out, of course, because I don't have 3-phase in my garage, or 480, or 240. That leaves us with 3 leads left over, 1, 2, and 3, which will tie to L1, L2, and L3, your incoming line. So, when you want to change rotation, your 3 incoming lines coming into this thing, you can switch L1 and L2, or L2 and L3, or L1 and L3. Either one of those two, and it will change the magnetic field so north becomes south and south becomes north. This switch here, there's a braking method called plugging, and we're going to talk about that real quick. It's not recommended for large motors. Basically, is what it does is by turning this switch, you're turning two of the phases, or swapping inside this mechanism to create the magnetic field to go backwards, which so you're like going forward, forward, forward. You release it, the motor stops, and you go backwards. If you're going to plug a motor and stop it immediately, you're going forward, you're going forward. All of a sudden, you throw that thing in reverse. That magnetic field changes so fast that it's going to stop that motor, just like that. Not a really good idea to do all the time. It's okay for smaller motors, but can you imagine a 200-ton press with a 75-horse motor and a huge flywheel? You're talking about an immovable object meeting an unstoppable force, pretty much. So, not a good idea. Before I get too far with the next thing I want to talk about, we're going to talk about this diagram here. You can see this. This is a stator, and each one of these is a coil, winding coil inside the stator. And you can see 1 and 4 right here. So we talked a little bit, and I think I had a video about how to check a 9-lead motor with a multimeter. So I have my little multimeter here, and we are going to check a few of these. The way you would do that is you want to take your leads. We'll start off by 1 and 4 and put our leads on one and 4. I lost my lead. There it is. Come on, baby. And you can see we got about 5 ohms. Okay, so we know that this winding is good. And we also want to do that with 2 and 5 and 3 and 6. And then we want to check 8 with 9 and 7. And we should get some, because we're going through 2 windings, it should be about half of 4 or 5, whatever that was. And then you want to take each lead to ground, which is, the side of the case here. And we should get some sort of ohm reading between each of these and nothing to ground. If one of these is open, the motor's bad. If we have a short from any of these leads going to ground, the motor's bad. And that's how you would check a motor with a multimeter. And you have any questions, you can feel free to email me or call me or text me or whatever. Next, I want to talk about real quick is VFDs. This particular VFD is a 480 volt VFD that I borrowed from my job. The ones we have in our lab that we are not able to use at this time because of the COVID-19 thing going on, have a 110 volt input with a 3-phase 208 output. And so we can actually run a 3-phase motor and do all the programming and stuff. But for practical purposes, I just brought this home just to kind of show you. First of all, there's a cover down here. You can see these numbers right here. There's L1, L2, point. There's L3, there's a T1, T2, and T3. And there's your grounds right there. L1, L2, and L3 is your line coming in from your panel or whatever, disconnect. The T1, 2, and 3 is the ones going to your motor. And it's recommended that when you bring in your ground, you land it right here, and your motor lead ground needs to come right off the VFD, not to like a lug in the panel or whatever. They recommend you take that because of electromagnetic interference. And we're going to talk about that in a minute too. But first of all, these are your inputs, and you have to program in all your inputs. If you tie wires into these things, and there's a diagram in the manual for this, so you do the wiring and then you have to do the programming. If you want to use the keypad for programming, you can start and stop it, speed control right here, all kinds of different things. Or if you have a remote start stop 100 feet away, you can tie them into here, start and stop the motor. You can tie a potentiometer through here somewhere and program that in for speed control at a different location. It's really a lot of stuff you can do here. There's a couple terminals on here that you can use for DC braking if you want to stop the motion of the conveyor or whatever it is you got running on this thing immediately. That DC brake, you can adjust the stop time, you can adjust like how fast you want it to stop, or how long you want it to stop. There's just a lot you can do with these things. They're pretty phenomenal. One more thing I want to talk about. This is actually a VFD cable. You see this thing here is a shield. It's a shielded cable. This thing produces a lot of electromagnetic interference. I actually put in a VFD on my job for a conveyor a couple months ago, and I didn't have any VFD cable, so I just wired it with regular cable. And the sensors that I have going to the conveyor that were electric eye and stuff like that for start and stop, zone control, I was getting a lot of interference because it was just going all over the place. I replaced it with VFD cable, and it's about a 50-foot run, and that seemed to take care of my problem because, well, no more issues. But anyways, there's a ground in here, and you want to take this right to the chassis of your VFD, and that leaves you a ground wire and 3 wires here, T1, T2, and T3. It's going to your motor. Now on your motor end, you don't have the shield. I cut it off, taped it up a little bit, and that's going to go on, whether it's wired 240 or 480. This is a 480 volt VFD, so we're going to wire up 480, and that's what we're going to use for incoming power. And there's your ground too. So that's what that's for. And all your control wires going to your start stops, your potentiometers, whatever else you got going on, they need to be in the shield too. And that pretty much covers everything I had here. So If you have any questions or comments, please feel free to give me an email or text or something. Thank you very much.